Right, so I want you to go ahead and pause right now and take a look at the problem, read through it. If you already have, then you can go ahead and just wait. We'll get right into it. So for the first thing that I want to do is I want to realize that I am trying to write a cubic polynomial function, meaning I'm going to have 3 roots and 3 factors, obviously. And then I need to satisfy my condition here that when the geographers have made it 300 feet in the horizontal direction, they will be 10,050 feet in the vertical direction, i.e. at the peak right there. Okay, so with that in mind, I'm going to go ahead and get started. And I know the 3 roots that I've got, right? So in writing my function h of x, I know 3 of the factors. I know, and actually, why don't you go ahead and pause right now and write it out yourself and see what you get. So you're going to have your first factor, which is x. Your second factor is x minus 800. And the third factor is going to be x minus 1200. Each of those will give you one of the roots needed in the question. Now, the next part is a little tricky. Okay, so what I want you to do is stop right now. I want you to test out the initial, not the initial, but the condition that when you plug in 300 for x, you should get 1050. And if you don't, I want you to go ahead and try to figure out what you could do so that you will. Okay, so that you can satisfy that condition. And then only once you've tried that, come back and we'll take a look. All right, so the first thing that I do is I plug in 300. And when I do that, I'm going to have 300 times negative 500 times negative 900. A little mental math here will tell me this is going to be positive. It's going to have 1, 2, 3, 4, 5, 6 zeros, which is going to make it millions. And 3 times 5 times 9, well, it's going to make it 135 million. Okay? So clearly, when I plug in 300, when I've made it 300 miles in the horizontal direction, I am far too high above the ground. So now we want to think about what can be done. Okay, what could we do so that instead of us getting 135 million, we end up with 1,050. Now, the initial thought, if you haven't done so already, pause and think about it. The initial thought might be to say, let's subtract some number. Okay, so in my equation, let's add on a piece where I subtract some number so that I get 10,050. What would that number be? Well, if I were to subtract 134,998,950, that would get me to my magic number of 1,050 when I plugged in 300. Okay? But I want you to stop for a second. Think about, would this preserve the other necessary conditions that I already have in place? Think about the roots again. Right? Remember, I need a root to occur at 0. Well, if I were to plug 0 into this equation here, I would end up with 0 minus 134,998,950. And that would definitely not be 0. That would be a very large negative number. I'd be so far beneath the ground I might pop out the other side. So that can't work. So I'm going to go ahead and nix this idea. That's not what I want to do. Okay? What's the other way that I could turn this astronomically large number into a smaller number? And there are a couple ways you can think about it. The first way you could think about it, and I think this is the most intuitive, is let's say I had 135 million, and I want to make it smaller. Let's divide it by some number, we'll call it n, so that we get 1,050. I should have used this color. And now we just solve for n. right? So in order to solve for n, well, there's a couple of steps. What I would first do is multiply by n on both sides. These would cancel. And then I'd have to divide by 1,050 on both sides. And so then I would end up with n equals 135, I'm going to put for the millions there, divided by 1,050, which would get me 128,571. So take a second now, stop, and think about what that means. That means that if we divided our function by 128,571, I would end up satisfying all my conditions. Check that the roots would still work. I would still end up with 0 in a numerator, and any numerator with 0 divided by any denominator is going to be 0. So that would still work. My roots would still be intact, and I would also satisfy the condition that when I plug in 300, I would end up with 1,050. But I want us to also think about it in another way, and I think this way is the most helpful and applicable in all situations. So if I have my function h of x, I'm just going to rewrite it here, x times x minus 800 times x minus 1,200. And I know that when I plug in 300, so h of 300 is equal to 135 million. But I want it to equal 1050. Another way of thinking about dividing by a number, and notice that this number that we got that we divided by was very big, it's the same as multiplying by 1 over that number, or multiplying by a very small number. So I could also think about, okay, 135 million times what number gives me 1050? And this is a little easier to solve because now we just divide by 135 million. These will cancel, and I'll get x is equal to 0.000000778. And this is the value that I will need to multiply my equation by. So my final function will be h of x equals 0.0000778 times x minus 800 times x minus 1,200. And this will satisfy all my conditions. It's even easier to see that this will satisfy the roots because I have multiplication all the way through. And of course, if you were to check, right, 1 divided by 128,571 is exactly this number that I'm multiplying by. And then you can go ahead and use this to then work on part B, which asks you, it says, hey, the lowest I should ever get is about 20 feet, and that should occur in the middle of the riverbed. So you would find a value you think is in the middle of the riverbed, see if that satisfies, if that condition is satisfied by the equation we have now. All right, so here we are going to try and write a third-degree polynomial to satisfy the data points given to us in the table. So I want you to go ahead and stop for a second. Think about what it is that you're trying to do, what you know, give it a try, and then press play again and see if there are any places where you messed up at all. Okay, so the first thing that we want to think about here is a third-degree polynomial. What is that going to look like? Well, let's call it f of x. If it's a third-degree polynomial, it should have three what? It should have three factors. Okay, so I'll just write them like this. And each factor should correspond to a root, meaning that each factor will tell me one of the roots. So let's consider the first root that we see here. When x is -2, f of x is 0, meaning if I plug in -2, I'm going to get a root, right? So what linear factor would give me the root at negative 2. Well, if I had x plus 2, notice that if I were to plug in negative 2, that would go to 0, and I would get a root. Go ahead and finish this out on your own. The next root is at 2, so I'll have x minus 2, and the last root is at 3, so I'll have x minus 3. Now, we might think that we're done there, but notice that in order for my function to meet all of these points, I still have to satisfy this point, which says when x is 1, f of x is 5. So think about what that says. That says f of 1 should equal 5. Well, let's consider what needs to happen for that to take place. The first thing that you should be thinking is, what is f of 1? What do I have right now, and then how can I manipulate it? Well, what is f of 1? Let's just write out that we need this to be the case. F of 1 is 1 plus 2 times 1 minus 2 times 1 minus 3. 3 times negative 1 times negative 2. So we'll have a positive 6. Not quite, right? I needed a positive 5. If we want 6, and we want to do something to 6 to make it 5, we're going to apply that same idea. What can we multiply 6 by to make it 5? Well, 6x equals 5 means that x will equal 5/6. That should make sense, because if I were to plug that in, 6 times 5/6 is going to be 5. The 6's will cancel. And so what this tells you is you need to have some coefficient which you're multiplying your function by. So my function will now be, go ahead and pause and try and write it yourself, 5/6 times x plus 2 times x minus 2 times x minus 3. All right. What is this coefficient here? What does it symbolize? Well, if we were to multiply all these factors out, notice that we then multiply each piece by 5/6. And so 5/6 is really the a coefficient here. It's the a coefficient. And why is that important? Well, notice that the coefficient, the a coefficient, its sign will help you decide on the shape, right? A third degree polynomial with a positive a coefficient, x to the third, will have this shape where the end behavior decreases going to the left and increases going to the right. Decreases to the left, increases to the right. If the a coefficient were negative, it would be the opposite. Right? Because the negative will just flip everything. And so now what was positive is now negative, right? And remember, it was positive to the right, so now it's negative to the right. And it was negative going to the left, but now it will be positive going to the left.